This is problem 5-9, it's on page 252. A hair dryer is basically a duct of constant diameter in which a few layers of electric resistors are placed. A small fan pulls the air in and forces it through the resistors where it is heated. If the density of air is 1.2 kilograms per cubic meter and the inlet at the inlet and 0.95 kilograms per cubic meter at the exit, determine the percent increase in the velocity of the air as it flows through the hair dryer. All right, so here's the system. We have section 1 on this side, section 2 on this side. There's a fan. It's blowing air across coils. So air comes in section 1 with a specific volume. Let's see, actually no, density, is that what they gave us? Yeah, it's density. They gave us density. So a density of 1.2 kilograms per cubic meter and a density of 2 of 1.05 kilograms per cubic meter. We're supposed to calculate the percent increase in velocity, so what does that look like? The percent increase in velocity would be the change in the velocity over the initial velocity. See, so think about it this way: if the speed doubled, then what would be the percent increase? Well, if it doubled, that's 100%, right? So if the speed is doubled, what the difference here is going to be just equal to the initial velocity. And so 1 over 1 is 100%. So that's the way it would go. But we could also write this as V2 over V1 less 1. And that's how we'll calculate our percent increase. So we just basically need the ratio between the inlet and exit velocity. Now the key here is to use a mass balance. The mass balance says that the mass flow rate coming in is equal to the mass flow rate leaving. Now we can expand this and say the density coming in times the area coming in times the velocity coming in. So notice this bit is the volumetric flow rate is equal to the density leaving, area leaving, velocity leaving. So if we rearrange this, we'd have V2 over V1 is equal to, well, let's see, the area, inlet, and exit are equal. So this is just the ratio of the densities between sections 1 and 2. And that is 1.2 over 1.05, which is 1.14. It's dimensionless, of course. And so the percent increase, let's see, V2 over V1 would be 1.14 less 1, which gives us a 14% increase. So there's the percent increase through the hair dryer.